Alright, so today we'll be talking about solving square root and other radical equations. Okay, so something like this. Pretty simple stuff. You minus the 3 to both sides. Okay, just remember, you always have to be taking your answer and plugging it back in as soon as you're all done. Okay, now with the odd, with the even root, you probably don't need to think about that as much, but it's always nice to just double check it and everything, okay? Alright, now, if you notice, this is not a complete square root, but it looks like this, okay? So you have to do that. You always have to do the outermost function first. And so what we're going to do is we are going to square both sides. Okay, and what that leaves us with is 3x plus 7 to the third power equals 25. Okay, and then what we're going to do is we're going to cube root both sides right as soon as that's done. Okay, now what happens is we get 3x plus 7 equals cube root 25. And now, as all you guys can know, we can do the square root of 25, which is 5, but we cannot do the cube root, so I just write out cube root. Then I go ahead and minus 7, so 3x equals cube root 25 minus 7. Okay, and then I'm going to divide everything by 3. So x equals parentheses cube root 7, cube root 25 minus the 7 divided by 3. And that's going to be my answer. And you can get the decimal and use that decimal, but this is just a nice number that you can actually work with. Now, what if you're given a rational in the beginning? Here's a trick. Okay, first off, once again, you still need to get rid of everything on the outside. But on this one, this is really cool. Okay, we're going to divide by 3. So we're going to divide both sides by 3. So that's pretty simple. Okay, and so we get x, parentheses x plus 2 raised to the 1/2. And this is why rational exponents are so amazingly good, because you don't have to think about, okay, I have to do this, I have to do this, blah, blah, blah. Okay, now, in order to get rid of this, if I had, here's the thinking with rational exponents. If I had a 1 here, I'd be good. But I have a 1/2. So, what I'm going to do is, technically, this is square root, and technically I would square both sides, just like what I did over here. I squared both sides. Okay. Alright, so technically, if I multiply, if I raise each side to the 2/1 power, those should cancel out to 1, those should simplify to 1s. And this is the really amazing thing, is that it's x to the 1/2 times 2 divided by 1. And then I do the other side. As long as I raise it to the 2/1 power, I'm good to go. Which, for you guys at home that aren't afraid of fractions, 2/1 is just 2. Okay, so what happens here is that these simplify to 1. It just turns into 1. And I'm left with x plus 2 equals 16. Okay, and then I minus 2 from both sides, and x equals 14. Okay, so something as simple as that just makes your job a whole lot easier. Okay, so on this one, once again, you still need to get rid of everything on the outside. I'd highly recommend get rid of the adding and subtracting stuff first. Okay, there we go. So I would minus 1 to both sides. And then I would change this to the power. So x plus 1 raised to the 3/5 equals 24, because I minus the 1 earlier. Okay, now I divide both sides by 3. So I got x plus 1 raised to the 3/5 equals 8. Okay, now in order to simplify this even further, it's going to be x to the x plus 1 raised to the 3/5 times the 5/3. I just multiply by the reciprocal. I just raise each side to the reciprocal power. Okay? And then I'm going to do the same thing over here. So this is going to be 8 to the 5/3. Okay? Alright, once again, these guys cancel each other out to 1s, and I'm left with x plus 1 equals, now I could also think about this in my head. I could put it in, I could seriously put this in Desmos. Desmos, hey, what's 8 to the 5/3? And what you're going to do is you're going to find is that they cube the 8 first, and then they raise it to the 5th power, so that is going to be 32. And then x equals 31. Okay. Now, once again, you're going to want to plug it back in and check it out. This one you don't need to do as much because you're doing a 5th root, but these ones you do need to check. So we need to check by plugging in 14 here, and we need to check. Oh, this one's ugly. You can probably tell which one I came up with on my own. Okay, by plugging it in here. When you plug it in, you should get 5, and then 8 equals that. So that works out. Okay. But solving square root and other radical equations, remember, if it's an odd root, you really don't need to solve for it because you can get negative numbers with it. But if it's an even root, you do need to plug it in just to double check it. I can kind of tell you right off the bat, since there's a plus sign, we're not going to be messing with something that much. Okay. All right. That is it, ladies and gentlemen, for working with solving square roots and other radical equations. Hopefully you have a wonderful day. Bye.